sections: 4.7, 4.8, and 4.9. Of course, 4.7 is the most important one and the longest one. The others are easy, and we will see that together, inshallah. To be able, Shabab, to solve the optimization problems, you need to follow these guidelines. So first of all, you need to understand the problem. How to check that you understand the problem or not? Ask yourself these three conditions, three questions. Ask yourself these three questions. What is the unknown? What are the given quantities and what are the given conditions on these quantities? And of course, if you can draw a diagram, it means you also understood the problem. So it is important in most of the problems to draw a diagram. Introduce your own notation. Name your variables, your quantities. What is constant? What is variable? And what is the quantity, the main quantity that you want to maximize or minimize? This is the most important part. Which quantity that you want to maximize or minimize? Let's call it Q. And you need to write Q in terms of the other variables. Then in the next step, you need to write this quantity as a one variable, function of one variable. Keep this in mind, one variable only, because what we are doing here, Shabab, we are studying functions of one variable. It shouldn't be two variables. And of course, use the ideas of the maximum and the absolute maximum and the absolute minimum that you have learned in 4.1 and 4.3. Also, you can add the following test for them, which is the first derivative test for absolute values. If the derivative is positive for all the values before C and negative for all the values after C, then this function has an absolute maximum value at C. And similarly for the case of minimum. Let's start with the first example. Read it, understand it, and solve it. You should always ask yourself, what is the quantity that we want to maximize or minimize? Let's read the problem. Find two positive numbers. So we have two positive numbers. Let's say x greater than 0, y greater than 0. These are two positive numbers whose product is 100. So what we have here, this means that x times y is 100. And whose sum is minimum. So now the problem, Shabab, is about minimizing. So we want to minimize which function? We want to minimize the sum. So let's write it here. We need to minimize the sum. We need to minimize x plus y. So this means that this is our function. We should have now a function of one variable. Let's say a function of x or a function of y. It cannot be a function of two variables. So now what we will do, we will say that we will minimize this function. You can call it S, by the way, from the sum, but it's okay. Now it will be x plus y. Now I cannot have, ya Shabab, two variables. I should have one of them in terms of the another one. Look at this. From here, we can write y as what?
100 over x.
100 over x. So now come here. Instead of y, write 100 over x. Now this is a function of what? A function of x, a function of one variable. And if you've done that, halas, what is remaining is mathematics now. If you can translate or convert the problem from word problem to a mathematical model, you are done. And this is what mathematicians do. This is why mathematics make the life easier. Of course, Shabab, most of you, they ask about the applications. Why we study this math? We don't need it. But when we come to the applications, they say, oh, let's go back to math. It is easier. Because really, it makes the solving problems easier. Now, what are the conditions on your x? Remember?
X more than 0.
This is the domain. You can just think that the domain of this function, is from 0 to infinity. Because if you have a critical number that they are not in the domain, or you should reject them. Khalas ya Shabab, I think now it is easy. You can continue now solving this problem easily. You will find the derivative. 1 minus 100 over x squared. You know how to find the derivative. If you don't know how to find the derivative, you don't deserve to pass Math 101. You should. Now, to find the critical numbers, you should equate it to 0. So both this equals to 0. You will have x squared minus 100 over x squared equals to 0. Now, this means that x squared minus 100 is 0. This means that x is 10, because it will be the square root of 100. So x is 10, and it is positive. طبعا, we cannot reject it. And if you want to check, you can do check on the sign, but for sure it will be here, because you are looking for minimum. It will be here positive and here negative, and you can check that. Look at the derivative. This is the derivative. Here it is. If you make, of course, just x minus 10 times x plus 10, like difference of two squares, it will be clear for you. Here, طبعا, we reject, يا شباب, we reject the negative one. Why we reject the negative one? We reject the negative because x here is positive. But by the way, negative 10 also is work here. It works. Do you notice that? This is why I said it is important to know what are the conditions that you have. So now, of course, if x is greater, sorry, this will be the opposite. If x is greater than 10, what we will have? We will have positive here and negative here. This means that it is decreasing here, increasing there. So this is local minimum, if you remember 4.3. But we have now the test for the local, for the absolute. So it will be absolute because there is no others. It is the only one on the whole domain. So this is absolute minimum, not maximum. So this means, shabab, that the number that x is 10. So what will be y? Also, y will be 100 over 10, which will be also what? 10. So the two numbers that we are looking for are 10 and 10. Any question? Look at the old exams, ya shabab. Many questions about this type of questions. When you have about number.
Doctor.
Yes.
Why did you put it x plus 100 over x here, f of x?
Did you work with us from the beginning?
Yes.
We said what we want to minimize.
The sum has to be
the sum. So we want to minimize the sum. We should have it as a function of one variable. ما ينفع تكون two variables. It should be one variable.
Yes.
I have another relationship here. What is it? That the product x times y
is 100.
100. Now I want this to be a function of x. So I want it to be a function of x only. So I have x plus y. I will replace y from this equation. From this equation, I have y equals 100 over x. So write instead of y 100 over x. Just we solved this equation. We
okay, thank you.
From here. Welcome. Okay, Shabab, is it clear? So what I will do, Shabab, next time, I will not solve the problem completely. Just if we can have our function, خلاص, I think you can continue, Shabab. Am I right? This is the most important step. If you have it as a function, you can solve it. Read this, Shabab. Try to solve it. Try to understand it. What is the maximum vertical distance? Vertical distance like this. And you have something here and something here. This is the vertical distance. Between the line y equals x, it is okay if you can sketch this line. At x when x is 0, it is 2, y is 2. And of course, this will be like this line. This is 2. And the parabola y equal x squared. Y equal x squared. Now we want to find what? The maximum vertical distance. What do you think? Where will be the maximum vertical distance between this line and this parabola? طبعا where x between -1 and 2. So we have x, we have our variable here. I don't know how it will be exactly because when x it will be negative here, -1 here. So now what we are looking for, ya shabab, is the vertical distance between this line and this curve. Let's say here or here, I don't know, but it must be here. So first of all, you need to understand the problem and to sketch the figure. So this is the figure, Shabab. Let's say this one, this is -1, this is 2. From here to here, it is the vertical distance. Now you have a point here and the point here. What you want to maximize. Maximize what? The function here, which is the distance function. What is the distance, Shabab, between this point and this point? And this point, it is on the line. So this point, it is x and y here. This point, it is x and y. But what is y on that line? Here it is. So you will write this point as هذه البوينت راح تكون x و x plus 2. And this point, it will be x and y, but it is on this parabola. So this point will be x and x squared. Here they are written here. You know the distance formula? The distance formula will be the square root of what?
y2 minus y1 all squared.
Because x minus x will be 0, by the way. X minus x will be 0 squared. So no need for that. Plus this minus this all squared. X plus 2 minus x squared all squared. But if you notice that he is talking about a vertical distance, so there is no horizontal distance. This will be 0, and this square root will be gone with this squared. So this will be gone. And what we have at the end?
Absolute value.
Distance function. The distance function, it will be x plus 2 minus x squared, absolute value. But of course, ya shabab, it is clearly that this line, it is absolute value. You are right. But clearly that this line is above. From -1 to 2, this line is above. So this means that this one is greater than this one. So this is positive. So no need for the absolute value.
Yes.
So this is my function, ya shabab. So it is the, let's call it f of x. We want to minimize f of x, and this, of course, is the distance. This is the distance function. Khalas, you can, ya shabab, continue now. No need, you don't need me now. Just find the first derivative. And you need to ask yourself the conditions on your x. Here they are. This is the conditions on x. If you have any x other than this of this interval, reject it. Now the derivative, it is 1 plus 0 minus 2x. If you put it equals to 0, you will have x equals to a half. Am I right? So x is a half. So it means that the distance here will be when x is a half. And you need to just to substitute. So what is the value of the function at a half? It is the maximum distance. We want to find the maximum distance. Here we are. This is the function. And he called it v, by the way. I call it f, no problem. It is at a half. And this is the maximum distance. Just substitute here by a half. Any question?
It's clear.
Let's go to the next one.
Doctor?
Yes, these problems are easy. We have a little bit difficult problems next.
Yeah, I know, but
slide.
we're
Yes.
substituting in the first line equation, I think.
In the function, of course. We are talking about the distance.
Which is x
not the
plus
derivative.
2. You just put a circle on x plus 2. Minus x squared.
Yes.
While-
Put a half here. Instead of x, put a half, and you will obtain 9/4.
Okay.
Excellent. Any other questions, Shabab? Okay. Let's go to the next problem. Again, we will just set the formula. If we can have the formula, it will be easy. Now we have here what? If we have 1,200 centimeters squared of material is available to make a box with a square base. So what we have here, we have a square base. Let's say this is the square base. Let's make it square as much as possible. Let's say this is square base. And it is a box. So it will be a box like this. Let's say something like this. So we have a box with a square base. So this means that, ya shabab, if this is x, let's call it p. Yeah, let's call it b because we are talking about base. Let's call it b. So this is b, this is b, this is b. It is squared. So with a square base and open top. So we don't have it. It is opened here. So let me make the last here. This top is open. So I will just make it like this to remember that it is not included. Because when we talk about the material, find the largest possible. So we are talking about maximum. We are looking for maximum. Find the largest possible volume. So we want to maximize the volume. The volume of what? The volume of this box. So what will be the maximum value for this box, ya shabab? You need to remember what is the volume of the box. If you have a box, ya shabab, what will be the volume of the box?
B
Do you
cube.
remember? It will be the area of the base times the height. So let me just call this one The height, let me call it h. I take just the first letter from b and the first letter from height. So what will be the volume of the height, Shabab? Of the volume of the box?
B squared times
squared.
h.
Times h. Yes. You should check that it will be centimeter cubed. Of course, this is centimeter cubed. It will be centimeter cubed. Now, this is the volume of any Shabab 3D object. Now, I want this function, Shabab, to be a function of one variable. Let's say we want it to be a function of b or a function of h. You shouldn't have it a function of two variables because these are variables, p and h. They are not constants. So what we need to look at the other relationships that we have. So we have here what? What is this? What is this 1,200? This represents what? Let me write it here.
Surface area.
B squared.
The material, it is a material that you want to make it. So this is the material, it is the carton, let's say, or it's the paint that you have. So it is the material that will cover the surface of the area. So it is the surface area, and you just look at the unit, it will tell you what is it. So this is the surface area. Now the question, what is the surface area of this box? So how many sides we have? 1, 2, 3, 4, 5 only. We don't have 6 here. So because it is open on the top. So let's look at the base now. For the base, we have what? B squared. Am I right? The area
Yes.
of the base. But we don't, if we were having the top, Shabab, if he said closed, we will have it 2 b squared, but it is 1. Now for the other sides, what will be the area of this side, Shabab? What will be the area of this side?
BH.
4x.
It will be BH, one side. I'm talking about one side, this side only. This side only, Shabab, it is BH. But how many sides we have? 1, 2, 3, 4. It will be multiplied by 4. Now I will use this relationship to write or to eliminate h or b. Which one is easier, Shabab, to be eliminated here? Which one is easy to be solved for? Is it easy to solve this one for b, or it is easier to solve it for h? What do you think?
For h, because
For
we can
h,
take
it is
b
easier because
as a
for
common
b
factor.
it is quadratic. For h it is linear, so it is easier, Shabab, to solve it for h. So from this equation, what will be h? 4bh will be 1,200 minus b squared. Divide by 4b. What you will have? You will have 300 over b. Am I right? Minus b squared over b. It will be b. It will be b over 4. Is that right? Why? Is it okay, Shabab? Now what I will do, I will take this h and substitute here. So now we will have our what? Our volume. Our volume will be what? The function. This is the function of what now? It is a function of what, Shabab? It is a function of b. By the way, if you want to write it x, usually we have it like x. You can write it x instead of b, no problem. Now, it is a function of b, so it will be b squared, this b squared, multiplied by h, this h, multiplied by 300 over b minus b over 4. Now, what it will be? It will be 300b minus 4th b squared. Now, this is my function of b. This is the function that I need to maximize here. So
b
what we will
cubed.
do, Shabab? We will
It's
find
b
the
cubed,
derivative.
doctor.
Yes?
It's b cubed. The last
B
thing.
cubed. Thank you. You are right. You are right. Totally right. B cubed. Thank you. Because we have another b here. You are right. So now this is the function, Shabab, that we want to maximize. What we will do, we will find the first derivative. I put all the details here for you, by the way. And this is the surface area. This is the volume, and this is what we have. This is what I mentioned here. The same that we had. Now what you want to do, Shabab, just find the first derivative and find the maximum. It is not difficult. You can continue, and this will be the maximum, the maximum value of b will be 20. And if you substitute in the original relationship, you will have the largest volume will be 4,000. Any question, Shabab? Let's go to the next example. Yalla, Shabab, think about it. Find the points on the ellipse. Oh, this is similar to the one that we solved, I think, for the two lines when we have a parabola and a line. So I think it is similar idea. Find the point on the ellipse. So we have an ellipse here. You remember how to draw the ellipse. This is an ellipse or this is an ellipse. And you know that is it vertical or horizontal easily. This will be x squared over 1 plus y squared over 4 plus equals to 1. And you can know that this one is vertical. It is not like this, it is like this. And it is centered at the origin. Now, of course, here this is 1, this is -1, and here you have it, of course, like 4 and -4, 2 and -2. And of course, you want to find all the points on this ellipse, all the points on this ellipse that are farthest away. So it is about maximum distance, So you want to maximize the distance from this point. This point 1 and 0, it is on this ellipse. If you check, if x is 1, y will be 0. So you need now to find the point. Let's say this one. Let's say x and y. It is arbitrary point. We want to find it could be 1 point or more on this ellipse that is the farthest away. أبعد نقطة عن هاي النقطة يا شباب. What is the point that is on this ellipse, and it will be the most far away from this point. So call it x and y. And of course, you know from here, what is it? You can write it as what? And use the distance formula. So this point, it is 1 and 0. Use the distance formula. What will be d? D will be the square root of what? X minus 1 all squared plus y minus 0 all squared. Now this will be equals to what? When you want, ya shabab, to minimize, طبعا this will be square root of x squared minus 2x plus 1 plus y squared. Am I right? طبعا when you want, ya shabab, to maximize or minimize the distance, remember that you want to differentiate. So you need to differentiate to find the derivative. And if you want to differentiate this function, it is about square root. So it will be a little bit complicated. The derivative here, it will be 2 times the square root. And here you will have the derivative of what is inside the square root. So instead of maximizing or minimizing the distance itself, maximize or minimize the square of the distance. So no need to have the square root. This is a very important trick that you have to learn and to use always. Now you need just to minimize the distance. Now remember, ya shabab, these are 2 variables. I want it to be only 1 variable. So I want the distance function squared, the square of the distance. I want it to be a function of x. So I want to replace y squared from where? From here. From here, what is y squared, ya shabab?
It's 4 minus 4x
4
squared.
minus 4x squared. So just replace this y squared by 4 minus 4x squared. Now, halas, you have negative 4x squared plus x squared. It will be negative 3x squared minus 2x plus 5. Now, this is the function. Now, just find the first derivative and find the maximum value. I sketched the graph here for you, by the way. And here you have the distance, then you have it as a function. Let me check that we obtain the same answer. Yes, of course. So this is the function that we want. He call it S, you can call it F, whatever. They are like your kids, ya shabab. Give them any name you want. Now you need just to find the first derivative, put it equals to 0, find the critical numbers, check that are they here or not. Yx is between -1 and 1, ya shabab, because you know this is an ellipse. What is the maximum? X is here. So x, it cannot be greater than 1. It cannot be less than -1. And of course, now you will solve it as a quadratic. You will factor, and you will find out that you will have at -3. The maximum will be at -3rd, and it will be 2 values. This is the point. You will have 2 points on this ellipse that they are farthest away from the point 1 and 0. Any question?
So we differentiate, huh?
Yes, yeah, Shabab, it looks like you came late. We agreed that خلاص, when you have a function, you can differentiate, Shabab.
Okay.
Because we have many problems that we need to solve today. Okay, so you can, after that, خلاص, you can differentiate. It is not difficult. You can do this work. Just find the derivative, then put the derivative equals to 0, then solve it, find x. That's it. Okay, and substitute in the original function. Find the dimension of the isosceles triangle for largest area that can be inscribed in a circle of radius r. This is a very important question, and I have noticed also that it is repeated. It is an example in your book, and also it is repeated in the old exams. Always, you may have a semicircle, you may have a circle, you may have a triangle, a square, rectangle, whatever, and you have something inscribed inside it. So what is the meaning here of the word inscribed? What we have here? What we have here? We have largest in a circle. So we have a circle, and we want to inscribe a isosceles triangle. What is this, Shabab? What is isosceles triangle?
Have two similar sides.
The isosceles, yes, it is a triangle with two equal sides of length. So this means that if you have two sides, they will be the same. So if this is x, this will be x. This is the meaning of isosceles. It has two equal sides of length. Two sides with the same length. So it will be inscribed. The mean inscribed, it is not this. It is not like this. This is not inscribed, ya shabab. Inscribed, it means that the vertex of the triangle are on the circumference of the circle, like this, for example. So this is inscribed. طبعا you could have it, ya shabab, in different ways. You could have it this way. You could have it this way. There are many methods to inscribe a triangle inside a circle. But let's take the typical case. Let's be like this. I think because we want to find the largest, I think this will be the largest. So let's say this is the center of the circle, and it is, of course, with radius r. So r here is constant or variable? Is it constant or variable r here, Shabab?
Constant.
Constant, so it is not a variable. So this is r. Let's say this is r, this is r, this is r. If you think about it, this will be r. Remember that this side is the same as this side. This is the meaning of isosceles here. So now we need to introduce variables. So it is typical, Shabab, to sketch the graph, of course, of the circle to be centered at the origin if you want, but it doesn't matter here, by the way. But you can think about this equation. You may need it, but we need to introduce some variables here, x and y. So what we will do, we will think about, since r here is a constant, so what will be the variable? What will be the variable? It is not an easy
the coordinates of the points of triangle.
What is it?
The coordinates of points of triangle, maybe.
It is a variable, but of course we need to get benefit from the sides of the triangle itself. So if you call this one, let's call this one. I don't want to call them x and y. So let's call this one for instance. Let's call it s. This is s and this is s, for example. This will be also not. I don't know what is this. But let me draw, because these are the same. So if I draw a bisector here, this will be, if this is t, this will be t, because this will be at the middle here. So this is what we know about the isosceles. When you have isosceles, if you draw a perpendicular line to the base, it will divide this into two equal parts. So this, let's call this t and this t. And what we will have here, we will have a triangle, two right triangles. And this is very important, very interesting relation that we have here. Now, according to that, let's focus on one. Let's focus on this one, this triangle. Now, ya shabab, when you change the position of the triangle, for example, to be here or to be here, and this quantity that is the quantity from here to here, it will be changed. So we have a variable here that it depends on the size. It depends from here to here. It depends, let's call it x. This distance from here to here, it depends on the size of the triangle, on the area. So if the area is like this will be, of course, maybe you will draw it at the center. If you draw the triangle at the center, for example, this x is 0. But if you draw it here, this x, of course, will be, it will help in determining the positions and the vertices of the triangle. Now, according to the Pythagorean theorem, Shabab, it will be easy to find the relationship between r and x and t. First of all, let's ask ourselves what we want to maximize or minimize. We want to maximize what, Shabab? The largest
S
area.
multiplied
What
by
is the
T.
area? Let's call it A, and we want to have it as an area of one variable. I don't know what is this variable, but I want it to be a function of one variable. So what is the area of the triangle? Do you remember?
Half
ST.
base.
The half of
by
the
height.
base times the height. This is the area of the area of the triangle, any triangle, of course. Now, our question, we know now what is the base, Shabab. What will be the base?
2T.
2t times the height. What is the height? Now it comes to the point that why we need to introduce new variable here, x, because before we introduce that x, it was like this. It was we know that this is r, but the height we need something here which is x. So now the height will be what, Shabab? The height will be what?
R plus
R
X.
plus x. Am I right?
Yes.
Now this is constant. Don't worry about r. R is a constant. We need to write this as a function of t or as a function of x. So we need to find the relationship between t and x and then replace it. Is there any relationship between t and x, ya Shabab, and r? Look at this
Yes.
triangle. Here it is. We have here x, we have here t, and we have r. So what is the relationship between them? R squared equals to x squared plus t squared. Which means if you want to replace what? We want to replace, ya Shabab, t. I need just t to be equals to the square root of r squared minus x squared. I solve it just for t squared. So this means that I will make it a function of x, only a function of x. So it will be a half. This will be cancelled, by the way. A half with 2 will be cancelled. You will have t times r plus x. Now what is t? This is t. So it will be square root of r squared minus x squared times r plus x. Now this is a function, Shabab, of what? Of one variable, which is x, because r is a constant. It is like 3, 4, 5. It is a constant. Let me check the formulation of the problem. I sketched this graph for you to be able to solve it, and here we are. We want to maximize this area, and which is exactly what we have. Now what you will do, Shabab, you will find the derivative, and this is not easy, not difficult, I mean. To find the derivative of this function, you will apply the product rule, the first times the derivative of the second. What is the derivative of r? R is a constant, 0 plus x, it is 1. Plus the second one times the derivative of the first one, and the derivative is 2 times the r squared minus x squared. Apply the chain rule, it will be negative 2x. Now you need, of course, to find the critical number. You need to simplify it. You will multiply this by this. 2 will be cancelled with 2, and you will have here r squared minus x squared minus rx minus x squared over the square root. And you need to put this equals to 0. And you need to simplify it and put it equals to 0. I will not continue this, Shabab, because we need to go to the next sections. So here we are. If you solve it, you will find that x equals a half r. Substitute in the original function here to find what is h and what is the base, what is the height, and what is the maximum area. Here we have a right circular cylinder. This is a circular cylinder. Of course, it is a right one. So this is something like this. When you have a right circular cylinder, it will be something like this, inscribed in a sphere. So it will be inside the sphere. Let me, because we don't have time, we still have only 15 minutes. So this is the cylinder, Shabab, and this is the sphere. And of course, the radius of the sphere here is a constant because it is given. Here it is. And of course, you will put the center of the cylinder to be at the center of the sphere to make it easier for you. And of course, you will make a right triangle here, and you will find the relationship between x and y and r. I put everything here for you. Now, what you need to do, you need to maximize the volume of find the largest possible volume of the cylinder. So you need to ask yourself, what is the volume of the cylinder, Shabab? This cylinder, the volume of it is the area of the base, which is by what? This is the base, Shabab. It is by y squared times the height. What is the height? From here to here it is x. From here to here it is x. So it is 2x. So this is, here it is. This is the volume of the one. Of course, we need to replace y or x here. We want it to be one variable, a function of one variable. So what we will do, we will find the relationship, and it is from Pythagorean theorem here. And of course, you can also find it from the circle that you have here. It is the Pythagorean, by the way, r squared equal to x squared plus y squared. Solve it for y and replace y to have it as a function of x only. Now find the derivative, solve it. It is not difficult. The most important step is how to find the function that you want to maximize or minimize. After that, it is just a matter of mathematics. Now, ya Shabab, 4.8 is also, it is very easy section. It is about how to find an approximated solution for an equation that you don't know how to solve. I will not go over the idea. It is here, by the way. The idea, if you want to find x2, just it is x1 minus f at x1 minus f prime at x1. x3, it depends on x2, and so on. So let's solve one question from this section. Here we are. We need here to find by using the Newton method, we need to find the solution for this equation. So we will call this, ya Shabab, now we cannot solve it explicitly, of course. We will call this f of x. So what we have, f of x will be 2 over x minus x squared plus 1. Next, we will find the derivative. It is negative 2 over x squared minus 2x. Next, we will apply, he gave me x1, and this is good, by the way. Now I will do what? I will find x2. He wants x what? x3. I will find x2. x2 will be x1 minus the value of the function at x1 over the derivative at x1. So what is x1? x1 is 2 minus, what is the value of the function at 2? What is it, Shabab? It is 2 minus the value of the function at 2 is what? This is the function. At 2, it will be 1.
Minus 4
minus
plus 1.
4 plus 1 over the value of the derivative will be negative 2 over 4 minus 4. Am I right? So it will be what? Equals to 2 minus, this will be negative 2 over, this will be negative a half minus 4. It will be negative times negative is positive. So it will be 2 minus 4. This will be in the denominator, and it will be 1 minus 8 negative 9. Plus, we said it is plus. Halas, we negative over negative is positive. And it will be 9. 18 minus 4, it is what? 15 over 9. Am I right? 18 minus 4, it is 14 over 9. So this is x2. What you will do, you will apply this x2. I think I also bought this yes. Then to find x3, you will repeat this. Both 14 over 9 minus the value of the function, and you need a calculator, of course, to find this. And this, usually these problems, it will be given for you in the study plan, not in the exams, when you need a calculator. It is important, Shabab, to learn how to solve this problem. How to use Newton methods to approximate the given number, correct to whatever decimal places. How to solve such problems. Now, this one, Shabab, we don't know what is it. We don't know what is it. So let's call it what?
X.
X. Then take the fourth raise both sides to the power 4. So what you will have? You will have this x equals to the power 4. Now eliminate this. Now this is your function. This is the function that you want to maximize or minimize. To find the root 4. So now you will find the derivative, which is 4x to the power 3. The derivative of 75 is 0. Now you will apply the formula. X2 will be equals to x1 minus f prime of x1 over f prime at x1. The question is, what is x1? Here you need to guess a value. You need to use your experience to start with a good guess. Think about what is x1? What is the best value to start with? Who
Three.
can tell me? 3?
Yes.
Why you thought about 3?
Because 3 to the power 4 is equal to 81.
We need, ya shabab, to find, you are right, we need to find the fourth root of 75. So what is the number the closest number that we can find its fourth root? What is it?
81.
81. And it is what? It is a 3. Because you know, ya shabab, that if you used, of course, 2, it will be 16. If you use 3, it will be 81. If you use 4, it will be 256. It will be far away. So it is a 3. So it is good to start with a 3, because when you raise it, when you put it here, it will be 81 minus this. It will be very close. So now, خلاص, if you start with x1 and x3, just it is a matter of substitution, ya shabab. Okay, here it is. X1 is a 3, all right, and here we are to find x2, x3, and of course it depends on a calculator, as I said. We will not ask you this in the exams, but in the study plan. I think I will skip a share of this question. It is easy. You will just put this equals to 0. You will move these to the other side. So you will call it f of x. You will find the derivative. Again, here you have a problem how to find x1. What is x1? What is the best guess that you need to start with? In such problems, you have to use a shabab radians. If you use a calculator, use radians, not degrees. If it is not given for you degrees in the denominator in the question. Now you need to sketch the graph of the function, this function 3 cosine, and sketch the graph of this line, this function, and this line, and see how many times they intersect each other and what are the approximate intersect points. So this is approximately at 1, this is approximately at -2, this is approximately at -4. So indeed here you need to start with 3 because you need to find the solution. There are 3 solutions. You need to start with the 3 values for x1, and you need to solve each one separately. I don't think so that will give you the questions like this. And the last section, Shabab, it is very interesting section. Antiderivative. Have you finished this section, Shabab?
Yes.
Yes, we finished it.
Good. So I think it is clear from the name, antiderivative. So what you will do, you will think in the opposite way. So for example, if you have x squared, previously when you find the derivative, you just find it. It is 2x. Very easy. Now you will do the opposite. You will ask yourself, what is the function that its derivative is x squared? This is the only difference. And this is, by the way, integration. Now it is the same when I ask you what is the antiderivative of x squared. I'm asking you what is the integral of x squared. This question is the same as the question of finding the antiderivative. And this is Math 102. This section is a connection between Math 101 and Math 102. Now, what is the function now? Ask yourself always, Shabab, dx of what equals to x squared? Who can tell me? It is
X cubed over 3.
x cubed of the power 3. What do you notice? It is just we add 1 and we divide by the new power. And this is a general rule for the powers. For the power rules, we will mention it. Not only that, طبعا, you can have also any function, Shabab, any function, x cubed over 3. If you add any constant here, it will be also true. If you bought 100, if you bought whatever, if you differentiate, you will get x squared. And this is what we call the most general antiderivative. It is the any antiderivative plus a constant. Now, this is Shabab the table. Now you need to make your table. You have before the table of the function and its derivative. Now you need to have a table for the function and its antiderivative. And remember, what is the antiderivative? It is the function that if you differentiate, you will get the original function. Here we are. You can write them also as integrals. This is like integral of this is equals to this. The same. This is what you are going to do in Math 102. And here we are, Shabab. This is the table. Now, to find the most general antiderivative of this function, I think the idea is clear now, Shabab. Remember this. When you have x to the power n, for any n, just without -1. -1 is here. The case of -1 is here. For any n, here it will be just x to the power n plus 1 over n plus 1. If you apply it here, the antiderivative f capital of this one, it will be 7. By the way, 7 is a constant. Don't worry about it. X to the power 2 over 5, you will add 1 and divide by the new. When you divide the Shabab, add here. It will be 5 plus 2. So it will be 7 over 5. Plus 8, x to the power -4 over 5 plus 1 over -4 over 5 plus 1. Simplify. It will be 5 there. 7 with 7 will be cancelled. 5x to the power 7 over 5. Plus, from where here? I got it directly from there. Now this will be there, so it will be 5 times. We should add it here. Why we didn't? It will be 5 minus 4. It will be 1 over 5. Okay, so this will be 5. It will be 40. X to the power 1 over 5. Plus what? Plus what, ya Shabab?
Plus C.
Plus Mr. C. Don't forget Mr. C. Okay, so this is the most general antiderivative for this function. I will not solve the next ones, ya Shabab. Here you need to simplify. Just make it 1 over t to the power half plus t over t to the power half plus t squared over t to the power half. Then it will be t to the power -half plus t to the power half plus t to the power 3 over 2. Now this is the function. You will apply what I did in the previous slide and you will get this. Here you will ask yourself, hey Shabab, when you have 2x, remember 2x when you differentiate it, it is 2x ln 2. But when you find the antiderivative, it will be 2x over ln 2. Don't forget that. Don't mix up between them. It is there. I need different kind of, okay, you have the derivative is given, find the function. The derivative is given, find the function. Ya Shabab, we will have it on the last minute, inshallah. If you have the function, find it. If you have the derivative, find the function. So you will just find the antiderivative. The antiderivative here, it will be the function itself. So here, if you have the derivative, how to find this? Do the opposite. It will be 5 x to the power 2 over 3 plus 1 over 2 over 3 plus 1. Now add it. What is 2/3 plus 1? It will be 5 over 3. Plus c, don't forget that. So this is the function. This will be equals to what? 3x to the power 5 over 3 plus c. Now, this is given for you to know what is c. So this is our function. Now, when x is 8, you have 3. When x is 8, what will be the value of the function? 21. So now you can solve it for c. So this will be 21 equals to what? What is 8? Third, 8 to the power third is 2. So 3 to the power 2 to the power 5 plus c. This means that 21 is, this is 32 times 3 plus c. And solve this to find c. c is -75. The same idea here, Shabab. But here just you need to, it will be secant squared t plus secant t tan t. This is the function. This is the derivative, I mean. Now, what is the function? The antiderivative. What is the antiderivative of secant? Ask yourself, what is the function that its derivative is secant? What is the function that its derivative is secant, Shabab?
Tan.
Tan. So this is tan t plus what is the derivative that its derivative is, what is the function that its derivative is secant tan? It is secant. Plus c, don't forget c. Use this to find what is c, and it is solved for you also. I put the final answer for you here. The same here, you have second derivative, ya Shabab, double derivatives. This is important one. So you will find the first derivative, which is the antiderivative of the second. Unfortunately, we don't have time. So this will be negative cosine, ya Shabab. The antiderivative of sine, it is negative cosine, plus the antiderivative of cosine is sine, plus constant. Then if you want to find the function itself, repeat the process. Find the antiderivative of the first derivative. Now, what is the this is negative, don't worry about it. The antiderivative of cosine is sine. The antiderivative of sine is negative cosine, plus the antiderivative of c. What is it, Shabab? What is the function that its derivative is c?
Theta.
What is the
X is
function that
4c.
its derivative is 4, for example?
Just
It is
x.
4x.
Yes.
So this will be cx. So we will have here cx plus another constant, which is d. This is very important trick, ya Shabab, in this question. I will just take from you, Shabab, 2 minutes, because they are the last class. It is the last class, and we need to have a photo, ya Shabab. We get ready to open your camera. We can take a photo together, and I will make a screenshot and share it with you in the WhatsApp group to just be a memory for us, inshallah. So now, if you want, ya Shabab, to find the value of the function at 0, the value of the function at derivative at 0. Now, f prime at 0 equals 4. What does that mean? Let's use it here. We will use it to find c. I think it was better to use it from the beginning. F prime at 0 equals to 4 means what? Means that 4 equals to negative 1, because cosine 0 is 1, and sine 0 is 0 plus c, which means that c equals to what? 5. Am I right? So this is 5, Shabab. Okay. Now, if you find use the value of the function at 0, it is 3. This means that 3 equals to 0, negative 1, plus 0 plus d. So this means that d equals to what? To 4. And the last, the specific answer that you have is this one. I think this is the last problem. No, we still have, but I will leave them for you, Shabab. The final answer is there. And that's it. This is all what we have, Shabab. If you have any questions, I will wait for you if you have any questions. But as I said, Shabab, if you would like, let's open our cameras and take a photo. Let me open mine. And of course, Shabab, if you have any questions, I will be glad to help you and answer it in during the office hours regarding these 3 sections. If you don't mind, Shabab, if you want to take a photo, we will take a together photo.
Doctor, this is
We'll
the
just
last
make a
class.
screenshot. This is a habit that I use, Shabab, to use with my students. When we have physical classes, face-to-face classes, at the last class, we take a photo together as a memory for us. And of course, we can do that also now online by, let me now extend it more to have the whole screen. Unfortunately, Zoom, it allows only 25 videos. Let me also stop recording. I think we don't need this to be recorded anymore. So you can, Shabab, use the record.